Hi, I'm Ethan Kwan, and today I'm going to be showing you, or telling you about, what density curves are. So density curve here, a little thick, so a density curve is, well, this is a density curve, so that's not a very good explanation, but, okay, so let's just review quickly. About what you should already know to learn about this. So you should know how to graph a set of points into buckets, like this kind of graph here. So as you can see, there are buckets here. So there's 1, 2, 3, 4, and in this bucket in here, this guy, that's all the numbers in this set. Maybe I'll move this over here. Move it over to here so we can see it. Okay, and get rid of that because that's kind of annoying. Okay, so anything in this bucket here, this bucket right here, this bucket right here, that is any numbers that fall into anywhere between 0 and 1. Okay, so for example, there are 2 here, so that's why there's a 2 up here, because there's 0.5 and there's 0.7. Okay, and for example, in this bucket here, this is all the numbers between 2 and 3 that fall into that bucket. For example, 2.1, 2.2, and 2.8. That's why this is at 3, so that's why it's at 3, right? And maybe this can be, maybe you went around, had a survey, how many hours of TV kids had, and every month, and then average that, maybe. So this, maybe that's what this set is. Let's just use that set, and then, so this isn't that many kids. This is like 16 kids. But if you did many houses, you'd get something. Well, you'd get something like this, right? And a better way to represent this data here is instead of using numbers here, we can use percentages. How many percent, how much of the kids did this much computer time? Or, for example, this first group, from 0 to 1, 2 kids out of 16. So 2 over 16 is 1 over 8, which is equal to 12.5. And, for example, this bucket here, 4 and 5. So there are 1, 2, 3, 4. So there are 4 kids that had buckets in here. So it's going to be 4 divided by 16, which is equal to, I'm running out of space, 1/4, which is equal to 0.25, right? So that's why it's at 25%. Okay, now, let's, instead of just a few data points, let's go around, maybe, instead of 16 kids, maybe 16 million kids, and see how much computer time they had. Well, if we do that, we have more buckets, which means we have much more data points to store. So that means maybe this is 1, 2, 3, 4, 5, 6, 7, and here's an outlier. 9 hours of computer time, that's a lot. And this is basically that. But what if you wanted a better approximation? Maybe you wanted to get a better representation of this. Well, to do that, you have to just put more bars in, right? Right? Okay. So if we put more bars in, this is what happens. So we have more data points. That means it's a little bit of a rougher graph. that means that there's more information to be stored here. Okay, but what if you wanted a better approximation? Well, if you wanted a better approximation, you could again just get more data points, as you can see here. This is a lot of data points, but what is this doing here? Weird. So this is a lot of data points. This is going to be very helpful if you want to maybe, I don't know exactly how many kids did what. Heck, even for this, we can connect the endpoints with a line. As you can see, there's a line here. There's this green line that basically represents all the kids, how much computer time they had. And if we want a better approximation, we can just get rid of the bars, and we get this. So this green area here is basically how much computer time kids used. Or TV time, I guess. So this graph is a very good approximation because technically there's no rectangles, right? Well, if you zoom in a lot, you might be able to see some gaps. For example, if we zoom in here, but it's very, yeah, this is as far as I can zoom in. Whoa, that's big. This is 1 point. Let's try 0.25. Woohoo! Okay. Anyway, this is not happening. Yeah, that's tiny. So someone's skateboarding in. Anyway. Okay, so let's see what you can get out of this graph. Let's remove the green area to get this. And I added some numbers in. And let's say you wanted to know exactly how many kids did 100% of, well, let's say we want to know the highest number of computer time everyone did. Well, that's going to be at the end of this graph if no one else did anything at the end there. If no one did anything here at the end, this is it, right? This is 100% of the whole graph, right? Or 100% of the area of the whole graph. And that's basically it. We wanted to, so if you want to know, let's say you wanted to know, let's say you wanted to know how many kids did between 6 and 8 hours of computer time. Well, we can figure that out by, we can use the line tool. We can figure that out by looking at the graph and going to the 6 and 8 here, and anywhere in between here, if we want to figure out the area, we could just basically, what is the area of this figure? That's how many kids did that much computer time, right? And it looks like it's about, maybe 20%? I'm going to guess 20%. So 20% of kids did 6 to 8 hours of computer time, right? Okay, so that's that. Now let's say we wanted to know how many kids did more than 3 hours of computer time. We can figure that out by looking at this area right here, going from 3, that's 3, right? and whatever this area is here, this area here, whatever this is, including this and this, how much computer time they did would be this, or maybe 80%. So 80% of kids did more than 3 hours of computer time, on average. Monthly, of course. Okay, here's one more question. How many kids did 5 hours of computer time exactly? So what I mean is, who did 5.000000000 forever? Who did this many hours of computer time? Okay, I'm assuming you thought about it. Now let's look at what most people would do. Most people would go to the 5 point, make a line, go to here, and say it's about 20% of kids, because it's there. Maybe like 21% of kids, because we looked at the graph, we got this point. We got this point, right? That point is on the graph, so they would think that maybe 21% of kids did exactly 5 hours of computer time, but that doesn't make any sense. Look, a line has no area, it only has length. And, well, in this case, there's width. If we extend this, there's width. But anyway, we're assuming that a line has no width, only length. That means that there are no kids that did exactly 5 hours. Maybe kids did 5, oops, I forgot to change it. Maybe kids did 5.1 hours or 4.9 hours, but that's not exactly 5. Even in our set of 16 million data points, I'm assuming that there is no person with exactly 5 hours of computer time. Or if we look at a different example, cups of water that people drank every month, and then divide that, take the average of all those numbers. No one person is gonna drink exactly 5 cups of water. It could be 5.0000001 or 4.9999999. And not just, like, it's gonna be off by maybe an atom of water, right? Or maybe a millisecond of computer time. So you can't exactly get this, but the way to figure this out is maybe you want well, there might be a lot of people between 5.1 and 4.9. So the way to figure this out is asking what is between what is between 5.1 and 4.9. What are the data points that are inside 5.1 and 4.9? Well, we can zoom in here, and so here's 5. So 5.1 might be maybe here. So 5.1 be there, and 4.9 would be here. So this area right here that I'm gonna shade in maybe green. And wait one sec. Just gonna make it the same color, and then we can shade it in, right? So maybe this area in here, this area is everyone who did 4.9 and 5.1 hours of computer time. If you ask me, I fall into this category. Or I'm not sure. I'll record someday. I'll put it in the comments too. Okay, so I'll tell you later. What is the area here? Well, we can approximate this with a rectangle. A rectangle is base times height. So, whoops. So we can approximate this with this rectangle right here with that is the base, that is also the base, and this is the height, right? So we can approximate the area with this rectangle right here. Now, how do we get this rectangle? Well, we know some of the values. Well, this length here that length is going to be 0.2, right? Because this is 5.1, this is 5.1, and this is 4.9, so 0.2. And for the height, we can look at here. It looks like about, well, we can calculate it exactly. It looks like about 20%, or 0.2. So the height of this is still on the line tool. Looks like it's about 0.2. Now, what is the area of a rectangle with 0.2, 0.2? That's going to be a area of 0.04. So that means that 4% of all kids did between 5.1 and 4.9 hours of computer time. And maybe I'll fall into somewhere between, well, every day I'd be maybe here. Totally, yeah. So that is my average screen time. We can calculate it. This is 7 hours. So this is about 7.1 and 6.9 hours, which means I am also around in the 0.04% of all kids that do this much. That's cool. Okay, well, this is kind of wrong, but anyway, see you at howtodosomething.com, and see you next time. Bye. Oops. Bye.